Great dear learners. In this video, you are going to learn Cambridge International Mathematics Paper 6 Investigation and Modeling Full Paper Solving. Now, I'm going to solve October-November 2020's component number 63. Let's get into the video and solve the paper. This investigation is about areas of polygon inside and outside a circle. You'll be getting 30 marks at maximum and everyone will be getting 30 out of 30. I'm wishing you for that. This investigation looks at the areas of polygons drawn inside and outside a circle of radius 10 cm. An inscribed polygon is a polygon in which all the vertices lie on a circle. This is an inscribed square. So you can see that square is inside the circle. A circumscribed polygon is a polygon on which each side is a tangent to a circle. This is a circumscribed square. So if you see, all the four sides are touching the circle circumference and they are acting as a tangent. And here they gave some of the formulas of area of circle, area of triangle, and the trigonometric 3 ratios. We know about it already. So here our first question getting started. A square circumscribes a circle center O radius 10 cm. Work out the area of square. So if we are going to find out that area of square, we need to know that the side length, they gave that radius is 10 cm, which means the diameter is 10 plus 10 is 20. If the side length is 20, we know that area of the square is 20 square. So 20 square is 400 centimeter square. Let's move on to the next question. Subdivision B is here. Still that circle's radius is 10 cm, but the square is inscribed in a circle. So if you are extending the radius to its diameter, then diameter is going to be 10 plus 10. It's actually 20 cm, but actually it is not a square's side. It's actually a diagonal. So if it's a diagonal, we have area of we can find area of square by using the formula of d square by 2, or else you can use Pythagoras theorem and you can find the side length too. So if you are using that, then you'll be getting the answer of 20 square divided by 2. It's 400 divided by 2. We are getting as 200. Next, show that the area of a circle radius 10 cm is 100 pi centimeter square. We know that area of circle is pi r square, so that pi into radius is given as 10 cm. It's going to be 10 square. So pi into 10 square, that is nothing but 100 pi centimeter square, and that's what we need to prove actually. So let's go to the next subdivision D. Area of inscribed square, area of a circle, area of circumscribed square. So these all are, they have written that inequality. Use the statement to complete the inequality below. So area of circle, just now we found it, it's 100 pi, and area of circumscribed square we found in the first step, it's 400. Area of inscribed square we found it's 200. If you compare the given inequality, it's 100, which means they have divided by 100. If you are dividing by 100, then this 200 will become 2, and then this 400 will become 4. So we have got that inequality, that is 2 less than pi less than 4 is the inequality. So we are going to the next question, 2a. So here they gave a regular hexagon is inscribed in a circle center O, radius 10 cm. Find the area of a hexagon. So maybe you can think that we need to know the area of hexagon formula. Actually it is not required, because we know that area of hexagon is nothing but 6 congruent areas of triangle. I mean, this hexagon can be divided into 6 congruent triangles. So we'll find one congruent, one triangle, one samples area we'll find, and we can multiply by that. We know that this height is also going to be 10, because that is a radius, and we know that what angle is this, because as I said before, since it's a hexagon, the total angle is 360 degree, and I said that there are 6 identical triangles are going to be there, so that we will be getting that angle value as 60 degree. So this angle is 60. So easily I can calculate that area of triangle as half into AB into sine C, the trigonometric formula what we know already. So half into 10 into 10 into sine 60 is what I have to use it here. But that is actually area of one triangle, and I have to find out that area of hexagon's area only I have to find. So as I said before, it's six triangles are there, six identical triangles are there, so this area I can multiply by 6 so that I will be getting the answer. If you put these values in your calculator, then you'll be getting the answer of 150 root 3, or else that 3 significant figure answer as 260 as answer. 260 centimeter square you can write it. So better if you write these values here in the actual given space, then that would be better. Then we'll move on to the next one. So B subdivision, actually here they made our work as easy. What's that? An equilateral triangle has a height of 10 centimeter. Find the area of the triangle. An equilateral triangle, if it's an equilateral triangle, we know that this total angle is 60, and since they are asking the area of triangle, I want the total length of this side, but by using the trigonometry I can find this side, this half of the side I can find it. Since it is equilateral triangle, then that altitude as acting as a median, so that this will be x and this is also going to be x. First I can find this x. It's a right angled triangle, so this side is 10 centimeter, and I know this degree is 30 degree, because the total 60 degree I'm only going to take this part because that is a right angle part. So 30 degree opposite side is x, and then adjacent side is 10, so that I'm going to use the trigonometric ratio tan theta equals opposite by adjacent. Since I want the value of x, so I can write this as 10 tan root 30, but I want the whole base, so that I can write that as 2x. So 2x is nothing but 20 tan 30. So now actually they have asked that area of triangle. So area of triangle is half BH. Here I'm not going to use the half AB sine C because I don't know the side lengths, the two included sides I don't have. So half BH is the thing I'm going to use. Half base, just now we found it is 20 tan 30 into height they already gave it's 10. If you put these values in the calculator, then we are getting 57.7 centimeter square. Now we'll move into the next one. Actually here they gave a hexagon, and then radius of a circle is 10 centimeter. It's resembling something. Yes, the triangle which we have seen before in this step is what here. So if you join them, then you'll be getting the same triangle what we found in the previous step. So just now we found that area of one triangle is 57.7, and we know that there are 6 identical triangles are there. So if you multiply your previous answer by 6, directly you'll be getting 346 as answer. 346 as the area. So even they have mentioned here, using your answer part 1, find the area of hexagon, so that the previous answer multiply by 6. So just you can even simply put 6 into answer button, so that you'll be getting your direct answer. So we finish this, we'll move to the next one. Use question 1C, question 2A and question 2B2 to complete the inequality. 1C it's 100 pi centimeter square. Previously we written that area of circle is 100 pi, and now here we got this answer as 346, and in this step we got the answer as 260. So as we did before, we have divided by 100, so here also we are going to divide by 100, so we'll be getting 2.60, and here it's going to be 3.46. Okay, then next they asked a question that give a geometric reason why the range in the inequality in question 2C1 is smaller than the range in the inequality in question 1D. So in the previous question also they have asked the inequality. Actually we got the 2 less than pi less than 4 we got, but now 2 increased to 2.6 and the 4 reduced to 3.46, which means it shrinked a bit. Why it has shrunk? Because previously we used a square and now we are using hexagon. So hexagon covers most of the area of circle when it is compared to the square. Square covers a bit area, but this hexagon covers maximum of a larger area than the square. So that itself we can give us a reason. Hexagon covers more area of triangle, sorry, more area of circle than square. Or you can even mention that hexagon has more area than square. Any one of the reason is enough. If you give this, it's fine, and that says your understanding. We'll go to the next one. Okay, now actually they gave here a regular 12-sided polygon inscribed in a circle, center O, radius 10 centimeters. So they are not changing the radius, it remains the same, the 10. And we know that here how many triangles are there. Previously it's hexagon, so 6 sides, and now it's 12-sided polygon, so 12 triangles will be there, and the side length, this is 10, and we just have to know what is this angle is. There are 12-sided polygon, so that the total central angle 360 has been equally shared by 12 identical triangles, so that you'll be getting that angle as 30 So one triangle's area is of AB sine C. So A is 10, B is also 10. So 10 square sine 30 because that angle what we found here is sine 30. And now we have to multiply this answer by 12. Why 12? Because 12 identical triangles are there. If you put these values in your calculator, we are getting the answer as 300 centimeters square. Okay, let's go to the next one. Yeah, so in the previous step they gave one baby step to find the area of triangle separately, then after that they gave the hexagon, but here they directly gave that 12-sided polygon. But we know the way, so let's try this. So if you are connecting like this, then yeah, actually we have one isosceles triangle. Okay, now this angle, what is the value of this is going to be? Previously, just now in the previous problem, we have calculated that angle as 30 12 identical triangles are sharing that 360 but here we are going to take half of it, which means this says that this is 15 and this side is what we have to find it. So let's take that as x itself. Why I'm taking x, why I'm not taking the previous value? Because here that angle is different, so that affects the side. So what I have to do here, I have 12 sides. So first I will find that what is the x value. It's opposite side, so tan 15 is equals to opposite side, that is x, and then divided by adjacent side, it's 10. Since I have to find out what is x, it is 10 tan 15 I can write. So now area of polygon is 12 identical triangles, so 12 into half into base is 2x. Actually it's not x, it's 2x. We found that x value, so 2x is going to be 20 tan 15 into height is 10. Yeah, just again just put these values in your calculator, then we are getting the answer as 322, so rounded to 3 significant figure. So use the answers to part A, part B to complete the inequality. Yeah, that inequalities, we just have to divide the answer by 100, so that we are getting here 3.22, and there we are getting 3 because that's 300. Okay, next. Show that a formula for the area of a centimeter square of a regular polygon with n sides inscribed in a circle radius 10 centimeter. So here they mentioned it's n sides. N sides says that previously we have seen that 6 sides after the 12 sides. Now they have mentioned it n sides. If you want, you can refer it before. Here actually the total angle we divided by the number of sides, so we got some angle. So number of sides, that is 12 into half AB, but that radius remains the same, 10 square. Sine that angle what we got here, that's what we have substituted it. So the same here also we can do it. The diagram is not given, but you just assume it in your mind, or else if you want you can even draw, not a problem. So here what are we going to do? Maybe for your understanding I can draw that too, but it is not possible to draw the so it's going bit extra, don't mind it, because if I keep it in the same place actually it won't give the perfect diagram. So this angle is what they said, it's there are n sides, so that it's going to be 360 divided by n is the angle, and the radius they mentioned it's 10 centimeter, so 10 10. Area of triangle is of AB sine C, so of AB it's 10 into 10, it's 10 square into sine C. So sine C value is here 360 divided by n. Since it's an angle, I'm just writing it in the bracket. And how many triangles will be there in this polygon? So there will be n sides, because sorry, n identical triangles, because it has n sides. And I can simplify this 2, and this 10 square is nothing but 100. If I simplify this, I'll be getting 50. So I can multiply them 50 into n, 50 n sine 360 divided by n. So actually this is what I have to prove, and yeah, I proved it. So we are moving to the next one. Show that a formula for the area b centimeter square of a regular polygon with n sides that circumscribe a circle. So what did we do here? So we are just going back to check what we have done here. Here the total angle is actually 30 degree. How did we get it? Because 360 divided by 12, because it's 12 sided polygon, we divided it, we got 30, and in that we are dividing it as two equal triangles, so that the 30 divided by 2, it's 15 actually. So the same process here also we are going to do. So we know that it is 360 divided by n, then after that again we have to divide by 2, because we are going to consider only that right angle triangle and the isosceles triangle. So this 2 will join with its denominator, or 360 by 2n, and this can be written as 180 by n. That simplified format I can write it. So what is this angle? Is this angle is nothing but so this angle is this one. Then I have this side length as x, but I want 2x, the base and height they gave us 10. So how can I find that? As usual, that tan whatever that angle I have, it's actually 180 by n is equals to x by 10. So if I want x, that is 10 into tan 180 by n, then I want actually 2x value, so 2x value is 20 tan 180 by 10. I'm getting it. So I want to find out the area of the polygon, so that is they mentioned as b. So how many identical triangles are there? It is n, because it has n sides, into of base is 2x, it's 20 tan 180 by n, into the height, it's 10. So if I simplify them, this 2 and 20 can be simplified into 10, then 10 into 10 100, 100 into n 100n into tan 180 by n. I'm getting And is it the same that I have to prove? Yes, the same. So I proved it. I'm going to the next one. Work out the area of a regular polygon with 100 sides that is inscribed in a circle, radius 10 centimeters square. Give your answer correct to 4 significant figures. So we are just going to use the previous formula. We don't want to think how many sides, how many angles, what is identical, everything that is not required. So just use the previous formula. What is the previous formula is, it's they gave, and we also proved it, 50 into number of sides. Actually here the number of sides is 100. So 50 into 100 into sine 360 divided by n, it is 100 again. If you put these values in your calculator, just check what is the answer you are getting. Yes, here we are getting 314.0. Why I'm writing 314.0? Because they are asking the answer to the 4 significant figures. Then next, work of the area of a regular polygon with 100 sides that is circumscribe a circle. So what is the formula we had? 100 into n. N is also 100 here into tan 180 divided by n. N is here 100 again. If you put these values in your calculator, then we are getting the answer as 314.3. Next, yeah, use your answers to part B to explain how you find the how you can find the value of pi correct to 3 significant figure. So let's do the inequality what we have done in the previous steps and previous subdivisions. It's actually 3 significant figure they have asked, so that if you are rounding the answers what we got to the 3 significant figure, we are getting 3.14. This will become 3.14 less than pi less than 3.14 again, because this 3 will get cut because we are rounding the answer to 3 significant figure. In the previous subdivisions, in the previous inequalities, if you have seen, it's like a 2 to 4, 2.6 to 3 point something, then again it get closer. The inequality, the area for pi, the sliding area for pi is somewhat a bit, initially it was high, then again reduced, shrinked, and now we came to a final answer, because the left side is 3.14 and right side is also 3.14. So pi cannot have the value, or pi cannot have the range of values between left side to right side. It's both are same, so it's getting a constant value 3.14. How did we get it? By dividing the previous answers by 100. So now what we have to write? So find the areas. Divide areas by 100, and we get the value of pi correct to 3 significant figures, 3SF. Because 3.14 is the pi value we know at to 3 significant figure. And why we did not take it before? Because that pi has sliding area between, I mean, this limit to this limit, but now that limit has been restricted, it's a single value, so pi cannot move anywhere, it's fixed to a particular value. So that also, if you want, you can mention it, maybe that says your understanding, but it's maybe, yeah, you can write. So yes, investigation is over and we are going to solve modeling. Let's start solving the modeling. Olivia wants to design a closed container with a volume of 1000 centimeter cube and a minimum surface area. Olivia uses a square based cuboid to model the container. Write down a model for the volume of the cuboid v centimeter cube in terms of x and h. We know that the volume of cuboid is LBH, it's L into BR, x square, so we'll be getting x square into h, or you can even write that as hx square. Find a formula for the surface area of s centimeter square of the cuboid in terms of x and h. So surface area, if it's surface area, then what we have to do, there will be 2x squares, so x square is one of the area, then hx is another area, then one more hx is another area. then everything will be 2 by 2, so front, back, up, down, right, left, like that. So that I'm just multiplying it by 2, and these two terms can be added. So if I'm adding it, I'm getting the answer of x square plus 2hx. Better I can take h as common again, so that I will be getting the answer of 2x into x plus 2h. So this is the answer I'm getting. Next, v equals to 1000, write h in terms of x. So v value is given, and previously we wrote that hx square equals to v, that is 1000 here. So that if you want h, it's going to be h equals 1000 divided by x square we are getting. Next, they asked us to write, show that 2x square plus 4000x. So maybe this is the thing we can use it here. So s equals to 2x square plus, so I'm just expanding it, so it is 4hx. I will be getting it. Now I can substitute the value of h because that's what given here. 2x square plus 4h is nothing but 1000 by x square into x. So this x and x square will get cancelled, so 4 into 1000, 4000. So I'm getting the answer of 2x square plus 4000 by x, because in the denominator we have x square, only one x got cancelled, so it's going to be 4000 by x, and that's what we have to prove it. Now work out the value of s when x equals to 25. So the value of s when x equal to 25, we have that formula, s equals to 2x square plus 4000 by x. If you substitute 2 into 25 square plus 4000 divide by 25, and you'll be getting the answer of 1410 centimeter square you will be getting. Next, sketch the graph of s equals 2x square plus 4000 by x for 0 less than x less than or equal to 25. So we have to draw the curve. If you put these values in your GDC, then we are getting the curve like this. And the maximum value what we have got for 25 is 1410. So it's important to mention, because for the x they have mentioned the range, for y they have only given the started value, that final value did not give, but we have to give, because when x is reaching 25, it's reaching the value of 1410. That's the thing we got in the previous step. That can be used for your v window value of your GDC too, that 1410 you can use it maximum. Okay, next, to find the minimum surface area of the cuboid. So you know that if you press G solve, and you can get what is the minimum value, we are getting that minimum value as 600. Then describe the container that gives the minimum surface area for Olivia's model. So if it's giving the minimum surface area, we can check what is the x value, because we have to tell about what container becomes big. We know that it's a cuboid, but let's see what is the value it's giving for the 600, because they mentioned minimum surface area, that we got 600. For the 600 we are having the x value as 10. If the x value is 10, we'll be having h equals to 1000 divided by x square. X square is 10, because just now we got it from the GDC, that's 10 square. 1000 divided by 10 square gives 10. So x is 10, h is also 10. So every sides are having that side length or side edge length as 10, so that it's not a cuboid, it's a cube. It's a cube of edge 10. Let's go to the next one. So the total surface area of this model is t centimeter square. Volume remains the same, it's 1000. Show that t equals to 2 pi r square plus 2000 by r. So first of all, we can write what is the t is. It's 2 pi r square plus 2 pi r h is what the value we have. That's the total surface area of the cylinder, because it's a cylinder shape. They gave the volume is 1000, so volume of a cylinder is pi r square h. So h value is what we have to find and substitute because there are no h here, and they gave that volume as 1000. So this steps will become 1000 equals pi into r square into h. If I want h, I will be writing that h equals 1000 divided by pi r square. So if we substitute the value, the what we got there for h, we are getting 2 pi r square plus 2 pi r into h value is 1000 divided by pi r square. So here pi and pi are getting cancelled, r and r square are also getting cancelled, so the remaining things are 2 pi r square plus 2 into 1000, 2000 divide by r. 1 r is remaining here, and even that's what we need to prove it, we proved. Next, to find the minimum surface area of the cylinder. So we have to find out the minimum surface area of cylinder. So how we have to find it? Are we going to use any formula or something? No, not required. Use this formula in your GDC for drawing the curve. If you are drawing it, then we are getting the similar graph that like this we are getting. Then let's check what is the minimum value we are having it here. That minimum value is 554 centimeters square. So here it is necessary to give the graph because sketching is important. That is an evidence we have it here. They did not ask us to draw the curve, so in that case we have to give that evidence that how we got this minimum surface area. We are not doing any calculations because differentiation integration we are not doing anything, so we are just getting from a GDC, just draw it. Next, to find the dimensions of the cylinder with the minimum surface area. So we can calculate what is the minimum surface area is giving the text length. There itself we can calculate it is 5.42 to the 3 significant figure, and we can get that height value by using that 1000 divided by pi r squared. So that there we are getting it's 10.8. If you want, you can check in this formula what is that h is equal to when r value we have. So next we'll be solving that next one. Olivia now uses a square based pyramid to model the container. In this question, the pyramid OABCD has a square, a base of side x centimeter and height h centimeter. The vertex of the pyramid O is directly above the center of the square base. E is the midpoint of BC. Then find an expression for OE in terms of h and x. So what is OE is, it's from the vertex to E, and we know that this is the altitude because this is going to be perpendicular and it's a midpoint. It's an isosceles triangle, so that altitude acts as an median acts as an altitude. So this is altitude. What is OE? OE, it forms a right angled triangle from the center. That is actually, this is a right angled triangle. We know that height is x and then side is base is x by 2. So how can you write this OE value as? OE is actually, OE square can be written as by using the Pythagoras theorem, but we can write OE directly, that is x by 2 the whole square plus h square we'll be getting, and if it's needed maybe we can simplify that to x square by 2 square is 4 plus h square we are getting it. So that is the actual value of OE. They did not ask OE square, so that only that square would take place here. So x square by 4 plus h square. So the next subdivision is the total surface area of this model is p centimeter square. So total surface area of this model, so this model, one base square and 4 triangles and the faces we have, and they gave the volume formula also. So volume is 1 by 3 AH. So V value is given, so 1000 equals 1 by 3 AHA is the base area, that we know that is x square because that base is a square. If you check here, you can clearly see that the base is a square, so it's x square. Now into height, and if we will be finding that h value, we will be replacing it. That's what we were doing in the previous subdivisions, the same. So 3 into 1000, it's going to be 3000 by x square, we are getting it. Now if you substitute these values here, so previously what is this? P is its total surface area, so P is equals, so base, that is x square, plus 4 triangles, we said it's 4 into half. The base is x actually here, because if you see this base, this full base is x, so of into base, it is x into height. What is the height? Actually the height is not h here, the height is OE, the value what we found in the previous, that we have to use it. It's actually square root of x square by 4 plus h. So after this step, immediately we can simplify this 4 and 2. So x square plus 2x into root of, so x square by 4 plus, so 3000 by x square. So 3000 divided by x square, it's not h actually, it is h square, so that this value also should be squared. So x square plus 2x into root of x square by 4 plus 3000 square by x square. So x square will be x power 4. 3000 square is, we are getting 960, we are getting it. Then in the next step we can simplify it, and in the same time we'll be taking that common denominator 2, x square plus 2x into square root of, in the denominator will be getting 4x power 4. So cross multiply it, x square plus x into x power 4, it is x power 6 plus 4 9s are 36, then 6 zeros, and this 4x power 4 can be taken it out, so that x square plus 2x into, if you take that 4x power 4 out, it is going to be 2x square, because it's coming out of the square root, so 4 will become 2x power 4 will become x square into root of x power 6 plus 3 6 followed by 6 zeros, will be writing it. Then here we can simplify things, and we'll be getting 2 will get cancelled, x and x square also getting cancelled, so that the answer is x square plus square root of x power 6 plus 36000000 by x. Actually that x should be outside of the square root, make sure that, and I guess that's what we have to find it too. Yeah, we proved it, sorry. Then let's go to the next one. Find the minimum surface area of the pyramid. So where do we go for the minimum surface area? Yes, actually here they gave the formula, right, that we proved it. This one can be used as an equation in RGDC to draw the graph, and if you draw that, then there we can get the minimum surface area, because that is the only weapon we have. So that is actually coming like this, and actually we need to find out the minimum value. The minimum value what we are getting is 660 centimeter square, that surface area is. Find the dimensions of the pyramid with the minimum surface area. So here actually we can calculate only the x value directly, so it is 12.8. so if x is 12.8, then with the help of the volume we can calculate, h equal to 3000 divided by x square. So in this, if you put, we are getting the h value as 18.2. Yes. Next, Olivia recommends the container. Okay, she is going to conclude it. She has tested cuboid, cylinder, and one pyramid, square based pyramid. Now she is concluding with the smallest surface area to a company. So smallest surface area to company, give a geometric reason why the company might not accept Olivia's recommendation. Olivia recommends that as, which has the minimum surface area. Let's check here. 660 is the surface area, and here we got 554, so yeah, here lesser than before, and here 600. So yes, obviously we found that answer that C has selected that answer as cylinder. Geometric reason. What is geometric reason? Why the company might not accept Olivia's recommendation? So let's see what Olivia is saying. Actually, Olivia wants to design a closed container with a volume of 1000 centimeter cube and minimum surface area. So she is working for a company and she is designing a model. She has suggested that cylinder because that has the minimum surface area. But why the company will not accept it? If you closely look into it, the cuboid, it is very easy to make the machines because the wasted material will be very less. Uh, Compared to cuboid, the square based pyramid will be having less number of, I mean, it has a bit more than cuboid, but it's okay in a square based pyramid. But if you take cylinder, we have to cut the circles in many other places. So mostly when we have a square and like this kind of shapes, and there, if you are using, if you're taking only the square, maybe that might be the reason why they gave in the investigation. So we'll be having this wasted area, especially in square. We have seen that many area are getting wasted. So because this is the one we can make it easily, and when we are going to cut it for the cylinder, wasted material is high. So why that company will not accept wasted material will be more in production? Because when they are going for the production of this container, then and where there will be more wasted material are going to be more. So that's why the company might not accept Olivia's recommendation. So yes, then yeah, so we have finished it and we have given the reason too. So that's it. This modeling is also over. We'll meet in the next video. Thank you.